Hi and welcome back to Programming with R and Matlab. My name is Ian and I'm Finance Station Assistant at Stockholm Business School. So today we're continuing our coding in R course and we are going to do a Sharpe ratio filtering. So this is our third logical block, and what we would like to do, we'd like to calculate Sharpe ratio, and we also would like to find the stocks which have Sharpe ratio higher than the market one. Recalling our basics videos, this is what we ended up with. So the calculation of the Sharpe ratio, we're going to use the formula over here, and we would like to apply it for each stock, and then for each stock we also would like to apply a Sharpe ratio filtering, where we'd like to filter it in this way. So let's first calculate the Sharpe ratio. We will switch to our RStudio. So now we're here. Let's create a new function and call it get Sharpe ratio. And we will also create a new function called get Sharpe ratio in here, and we'll name this function. So what it is needed to calculate Sharpe ratio? We need to calculate the expected return of the stock. So for this we need to first calculate the returns. We're going to use log returns. Then we would like to have the risk-free rate and standard deviation. Okay, so to calculate the returns we need prices, we need risk-free rate, it's here. And as you remember, maybe you don't, if you take a look at our raw data, our risk-free rate was in percentages, so we need to convert it. So this is actually 1%. We need to divide it by 100, and then we can make operations with it. So for this we just divide it by 100 here. So next, what we would like to add, we'd like to do it for each time period, because we just want to have a time variant Sharpe ratios. So for the number of time, now we're opening the bracket and we're going to write create an empty vector. Create empty vector for Sharpe ratio. So some of you may ask, does it really need to create empty vector or not? Well, as a rule it does not need it, but it makes your program more stable and it makes it run, it just makes it to run faster. So it's really good to do it and to have it as a habit. So we'll call it Sharpe ratio, and we would like to create a vector which will have equal numeric. Let's make it in a fancy way. And then we would like to have Sharpe ratio for each data point, so we'd like to say it's for number of time. Then we would need to calculate log returns. To calculate log returns, we will create a special variable. We'll call it log returns, and to do this we're going to use the function diff. It finds the differences, so pretty much what it does, it subtracts the previous value from, the current value from the current value. It subtracts previous one. So if you go in here, what it will do, it will take element 1 and subtract it from element 2, and this would be the element 1 in the new matrix. So when you do this you will lose one observation, just so that you know. And then we would like to do it on logs, on the natural logarithm of prices. So after running this it will calculate as log returns. And what do we need else? I think that's it to calculate the Sharpe ratio. So now we would like to apply it for all data points, and what we have for ID time from 1 to the number of time minus 1. Why it is so? Well, because we're losing one observation. We would like to do Sharpe ratio at the time plus 1. Why we're doing this? Well, because here we announced that it's going to be equal to the number of times. So here we didn't lose any observation, but here we lost 1. So in order just to link it and to make it kind of on the same data frame, we need to add plus 1 to this time point. And what we'd like to do, we'd like to calculate the Sharpe ratio, and the Sharpe ratio is mean of the prices, not prices, log returns, starting from the first date, ending up with the ID time, then minus the value of the risk-free rate at time plus, so time plus 1, and okay, and this is our mean, and I think I put too many parentheses here. Yeah, now it's good. No, I mean brackets. Now, yeah. No, it's parentheses. It's well, then we would like to divide it on the standard deviation. So it would be standard deviation. It's a function SD of our prices, or again log returns starting from 1 to ID time. That's it. After this, it will calculate the time variance Sharpe ratios, and we would like to tell the function to return them as an output. Add return here, and do not forget to put the stock prices. We will just copy them. Then we would like to include our risk-free rate. We have already calculated it in here, and number of time also was calculated before. Good. So right now we are saving it, and after this we are going to have our Sharpe ratios, and we can apply the Sharpe ratio filtering. But before doing this, let's think a bit globally in how it will fit our whole general framework. We want stocks to have moving average by signal and high Sharpe ratio. And when you can use this word "and" in constraints, so it has to be bigger than 5 and lower than 3, for example. Well, it doesn't make sense that much, but I think you got the idea. Then you can actually combine these two if statements, and we're going to use it together with our moving average rule. How are we going to do it? Well, you go back in here and you go to our if statement. Here it is. Then you add one more parenthesis over here and write double and sign. Here it is. And then you just add another restriction. If you want to add or instead of and, you write it like this. But we would like to write and. So we would like to select the stock data, which will have a specific ID. Then we would like to select a Sharpe ratio for this specific point of ID time. Here, and we would like it to be more or equal to the market's Sharpe ratio, and for this market is number 1, and then we're selecting Sharpe ratio at a specific point of ID time. Good. So now, well, it's quite a long line. So now we do have it in here, and it's just, yeah, the first bracket, the second bracket, this one, this one, this one. Yeah, there it should be correct. Good, and still we're going to have this signal for now 1 or 0, and we would like to save it. this. Let's just run the code and see how it will work out. So again, we updated low stock data. We need to run it source. We need to make stock data. Okay, time plus 1 dynamic argument. Okay, what's wrong? Oh, yeah. You see, I write a time, but it was ID time. Okay, so now again rerun the code and then rerun the data. ID time. Oh, ID time, ID time, ID time, ID time. Now it should work. So far so good. Yes, now it has done, it's calculated all the ratios, so let's run this. And then let's apply the whole thing. Okay. Error in if missing value true or false is needed. Okay, let's just run it like this separately. I think there is also a problem with this one. Okay, it says NA. Why is that? Oh. ID time is equal to 2. So let's take a look at the Sharpe ratios over here. Well, there is... okay. We see here we have NA. So maybe we have some error when we were calculating the SD over here. Yeah, I think this happened because we dropped one observation. So this is why it says that there was no standard deviation at all. So to get rid of this error, you would like to then overwrite it somehow, and for this we can try saying that start from the second one, then it will leave it to 0 as well. Let's then rerun this and then rerun that one. Good, and then we'll just rerun the whole thing. Bam! So now we have our temporary portfolio. So let's take a look. Are there any... okay, we can see it, but we can import. Oh. So at the very last time point, there is no stocks which have the higher Sharpe ratio than the market one. This is why it said that there is no stocks to select from. Okay, so this is it for today, and we have crossed out our third logical block, only 2 left. Thank you for watching. Please press here to play next video. See you and good luck.